So today let's take a look at this Branson ultrasonic cleaner. This cleaner is showing no power. It is model CPX8800H, so it has the heater function. The switch is on. It feels like it's got a good click to it. We can test this later, but we're definitely getting 120 volts to the plug here. And no display whatsoever, so we're definitely going to have to get inside this. I've never worked on an ultrasonic cleaner, so this ought to be interesting. Cut it off and go ahead and unplug it. We have several number 2 Phillips screws around the top lip. Most of these are pretty short. These 2 here are longer on this right side here, and 3 in the back were longer as well. Don't know how far we can lift this, but yeah, not much further. There's a ribbon cable in the back that's getting kind of tight. We see our 6 ultrasonic transducers, so we see how these transducers are mounted on the bottom, and this is our heater, and there's our control board. So now on the bench, we're just going to take time to take this board out. I've removed all 6 of these red connectors that go to the ultrasonic transducers. We're going to remove our tank heater wires here, and we also have a common black wire that goes to the transducers. These white wires here are actually the thermal. There's a little thermal cutout switch here on the tank, so that's what those are. We can remove those, and polarity should not matter on these at all. There's that common black wire. We also have our power to our heater that also goes through what looks like a built-in temperature cutout and comes back through by this relay. These 2 white wires, so those are obvious where they go, and the ground wires. That ribbon cable popped right out, and we have a couple small white wires that go up to the display board here. I'll try to show some detail about that later because I could barely reach it. And we'll get this whole top part out of the way for now. So we're going to have to get to know this board here pretty good. We got a lot of issues already showing with this board. We'll go ahead and remove the incoming power connectors. And we have, looks like 8 number 2 Phillips screws holding the board in place. We do see some corrosion here, and a little bit of the solder mask is gone, but no big issue. This will clean up pretty good, but we'll get this on the bench and take a closer look. And back now, you might be able to see from here we have a 14-pin chip as well as some resistors. It's completely blown. This fuse is gone. This other fuse looks good. The MOVs look good. Lightning probably didn't cause this, but something power related definitely did. I think this was damaged during our storm in the end of September. Storm Helene got us pretty good, and the power did some crazy things during that storm, so I believe it got the board in this ultrasonic cleaner that I'm looking at for a friend of mine. If we take a closer look at the board, we can see this chip. It looks like a LM324N, so that's going to be a quad op amp. It's blown, some resistors blown. This is actually a power resistor that's blown. It's not common to be that black around it, even though the top part looks good. We keep looking around here. Nothing else is very obvious. Let's bring over the microscope just to make sure you can see how bad the damage on this resistor is. And R13 and 14 are going to be very hard to verify the value because R13 was definitely blue and maybe started with brown, but that's all we see. Again, I'm glad this chip does have the number on it, so it's just a basic quad op amp. Should be readily available. We're going to have to check all these little transistors for sure. A lot of PN junctions are going to be suspect, as much damage as this board already has. You might can see up close now that the fuse definitely took a hard pop. It's black at the bottom and elements all melted in the middle there. This is kind of an odd one because this is going to be at least a 2-watt power resistor, so it's going to be fairly low ohms typically. And brown, black, silver, and then red, it looks like 0.1 ohm. That much black around a 0.1 ohm 2-watt resistor. More than likely it's not still intact. Just looking around the transformers themselves, no obvious black marks or smoke. Using my autofocus Elcliffe microscope here, and it is handy coming through the board because it will autofocus without keeping the manual adjustment going the whole time. And we do see these components look nice, but we're going to definitely have to check them out. No other resistors or diodes smoked that we can see. A lot of high voltage caps around here. This is going to be a high frequency output device. High voltage caps are going to be necessary for sure. We oddly see a lot of small amounts of solder flux still on the board. Still a little unusual, being a unit that's several years old like this one, especially maybe being from a company that specializes in ultrasonic cleaners. But the board overall looks really good. This is a very thick board, so this board is going to take a lot of heat to work with. I have come up short trying to find any information on this board. I can't find any photos online that may help me figure out R13. I've contacted a few people, including Process Equipment and Supply, that had their label on this actual unit that may have sold this piece of equipment at some point in time. As I asked about the schematics or any information on the board, none were available, but the board was still available to purchase at $960. So good that it was available, but for that price we're definitely going to see if we can fix it. So going to bring our meter over in continuity mode first and just show that I have already replaced this fuse. So the easiest job by far. I didn't want to forget to do this later on if I'm testing maybe down the road. And just to show you here, we're good on that fuse, and we won't have to really talk about that one anymore. Maybe that was fuse 2. My biggest concern is going to be these resistors that I just don't know the value of and can't find any information on. And anybody out there with any information on this particular board, if you could share that in the comments, it would be greatly appreciated. I've cleaned this board up a little bit, and R14 may be good. R13 is definitely gone. You can't even tell remotely what it was close to being. RS1 they call it here, as a 0.1 ohm power resistor, definitely shot. It actually smoked up the board, as we remember, beside it. Go to diode check mode here, and these diodes are going to be hard to check. As you can see here, it shows like we're shorted, but this looks like a 150 ohm resistor, this across it. So any low ohm reading across it, it's going to be hard to check without lifting one side of these, and I might have to go through and do that. This one here, for example, D2, 0.2, as we change the polarity, still 0.2 volts. So that doesn't look good, but I think that's because it's a relay coil. So we have a fairly low resistance across that diode, and of course it's going to show both ways. This one here shows like it's shorted, but that's also a 150 ohm resistor there, as well as this one. And we could be connected to output transformers and things of that nature as well. Don't have the schematics at this point, and probably won't get them. And since we don't have the schematics, it's going to make it very hard. But here we go, it's 0.2 on this one as well. See both ways on D1. And this is another relay. This is for our heater, so I won't worry about that one because of that coil or the relay showing that reading. But as we go through here, I want to check these IGBTs. So we have 4 IGBTs that are the high current output and probably high frequency output for our ultrasonic transducers. I don't have the meter on the screen, but they're showing shorted. But in case you can't see this, I'll give you up close here in the top right. I definitely see where these have let the magic smoke out. If we flip up the top and look at the other side, wow, one of them's cracked really good. So I'll show up close of this one as well. Looks like we have a small air pack temperature sensor for the heat sink. I thought that was a diode to start with, but it's definitely a temperature switch. And this other IGBT, if you can see that, it has also let the smoke out of it. Whew, this is going to be a big job. So we already got the 4 main power devices failed. As I go across these IGBTs, they're definitely shorted, but we won't know about these other components until we get these out or swap them out. So they're obviously faulty, so I won't spend much more time here. And of course we got the big power resistor as well as the op amp and the resistors that we just don't know about. So that's 2 IGBTs here. Of course we have 2 here. So we're racking up a good many components. The good news is this fuse here was also good. I took it out and I checked it, and this little small power supply here is good, so that's great. I believe it's going to feed part of this 16 pin chip here that is a TL5941N, so maybe it survived. So I'm going to order a lot of these components, and we'll be back once they come in. So back now, the DigiKey package has arrived, and I've gotten several components this first go around. I have the IGBTs. These are the 10 NC60KD. and I ordered 5 of these. I know we at least need 4. I also ordered 4 of the 2-watt 0.1 ohm resistors. I just don't have many 2 watts around, so while I was ordering some, I ordered more than one in case we do have a failure when we go to power it back up. But this is also a 2% resistor that I'm replacing, and I could only find 5% that were in stock at the time. But at least they are 2 watts, so I did guess the wattage correctly based on the size of it. So we're going to use that one. And I also ordered a couple of the op amps, the LM324N, very common op amp, but I did not actually have one in stock. Hopefully I will now because I went ahead and bought 2. We talked about this before, but a lot of times the shipping and handling costs more than the parts, so a lot of times when I'm getting components I will get more than one. So the first thing I'm going to do is remove the op amp. I think I mentioned earlier that this is a very thick board with some thick layers, and it's going to take a lot of heat. I'm really hoping my little desoldering gun here will help out, but I'm not going to hold my breath. This is going to be one thick board, but this gun usually does really well if I can get it to melt all the way through and then wiggle the pin and it'll pull up, and it usually will vacuum out the solder. But you can tell I am struggling to melt the solder well, so I'm going to go ahead and add some flux and add some fresh leaded solder to this unleaded solder, and we'll see if by loading it up with solder here if it'll help us get the melting point down enough to flow well. Definitely better, but not all the way there, so this is not looking promising. I'm going to fast forward through a lot of this. So I'm just going to take some solder wick, the braid, and I'm going to pull off as much of the unleaded solder as I can. And I apologize also, I lost my mic during a lot of this repair, so a lot of the bench testing won't have the actual sound of the bench testing. And I'm just going to use the low melt solder trick here. It's going to be better on this thick board with these really long plated through holes for the components. We're just going to mix in this low melt solder with the unleaded solder, and those solders together will be a lot easier to remove, and will even stay liquefied for quite some time to make it really easy to work with. Just going to work it in and hopefully it gets through the board. But I'm going to put some on the top here too as I pull one side of this IC up and out of the holes. And it's definitely moving easy. Going to go ahead and pull this one side out. Not a problem. I'm going to use my pliers here on the back on the chip while I apply the heat with the soldering iron on the other side of the chip. And we'll stay liquid pretty good there, and yep, it pulled right out. So there we go. I'm going to reuse some of this low melt solder. This stuff isn't cheap. I'll take this and use it on some of the other components here as well. I'm going to remove the screws from these IGBT components. These have little clamps that hold the 220 package to the heatsink, noting that it does have the little thermal pad. We'll make sure they're not damaged, and we'll make sure that we also put them back in place. So I tried a couple methods here on the IGBTs. The low melt solder ended up working the best. I'm going to remove that Fire-Right bead and put it on the new IGBTs. There's one out and 3 more to go. So this is the method that worked best. I'm going to put some flux. Going to work in a little bit of low melt solder. And note earlier that also I switched over to my widest tip. So this is my Hakko 70 watt iron, and this is the widest tip that I have. And it's doing an excellent job here with this board because it is so thick. It's just a lot of thermal load on a lot of these components and traces and planes. This wide tip can get on multiple pins at one time, which is helpful. And there we go, number 2 is out. I'll do the same thing with the other 2, and we'll come back and clean up. Also going to clean up the area around the op amp. Just going to use the flux and the braid. We definitely want to get up all of this low melt solder, as I've mentioned in many repair videos. This stuff works excellent for removing things, but we don't want it on the board at all when we go to solder back, because it can make a weaker solder joint and lowering that temperature of the joint itself. Also going to clean up where that resistor goes. Now we're going to clean up the front side of the board, around the op amp, around the IGBTs. We'll speed up through a lot of this because this is going to be a pretty long video. Now let's remove that 2-watt resistor. This is really going to take some heat. I can get out my 140-watt iron if I need to, but I think this is going to be okay. I'm just going to remove as much of the lead-free solder as we can. I'm just going to puddle up some of this low melt solder and let it work in. And I should be able to just pull that resistor out. Yep, there's one side. We got to grab it again here, and yep, that's the other side. That low melt went all the way through, as you can see it there on the resistor lead. Go ahead and clean some of this up. We'll clean up both sides here. Awesome. I'm going to go ahead and remove this resistor. And yeah, there is no way to get any information off of this. It was blue and it was brown on the first band maybe, and that's all we know. So it'll probably be a 0.1 to a 1 meg, or who knows. Going to get some alcohol here and clean up. Use a Q-tip. And I'm going to grab my lint-free cloth here next time. I'm going to go ahead and get out one of these quad op amps. I do have to bend these pins a little bit. That might not be in the shot. Let me get over here. There we go. I just want to get these pins perfectly straight. That should fit in there just fine. Also going to grab one of these resistors out. Just going to bend the leads and go ahead and put it in place as well. I'm going to push it down. There we go. Bend the lead so it doesn't fall back on me, and make sure the chip is pushed all the way up. I'm also going to bend the little tiny pins on this chip enough to hold it in place. So now we're just going to use some flux and some leaded solder and solder these components back on. Definitely going to fast forward through a lot of this. It's going to be a lot to watch. Make sure, let me make sure that chip's still up, and it is. Secure the opposite corner, and we'll go ahead and do them all. Go ahead and clip the leads. Do a little cleanup. And now we'll do the IGBTs. And I just pulled open the little sleeve they came shipped in. As mentioned, I got to pull the little ferrite beads off and put them on pin 2 of each of these IGBTs. That's the old and the new side by side. I do have to take that middle pin as well and bend it out just so slightly to fit in that offset of the plated through holes. And there we go, it slides in nice. Making sure that our thermal pad is still there, and that we take our little clamp and at least snug it up for now. Just want that to be in place before we solder it, so we don't stress it trying to tighten it up to the heat sink after we have soldered it permanently in place. Maybe a little bit more right there. There we go. Do a little cleanup. Cut the leads flush. A little bit more cleanup. And there we go. Just 3 more to go. So we'll do one on this side. Get our thermal pad in place, and that's the little stud that fits over the top tab of the IGBT. So that just goes in there, and then we push down and get our screw started. And yeah, we just want to snug that up before we solder the pins well. So we'll go ahead and get one on this side. And there we go. We'll cut the leads and clean up. And there we go. We got one more on each side to do. We'll rush through that really quick here. That's what that side looks like now. And we just got one left to do. The large tip just helps tremendously with this thicker board. We'll clean up, cut the leads flush, and the IGBT should be done. And there we go. That's this side. And that's the other side. That's what it looked like from my angle. So I have lifted R14 as well as removed R13. After cleaning R14 up, I believe it's fine. It should be around 100K and it's 99.4K. It was just set it up from R13. R13 just almost evaporated on us. So I can put R14 back. That way I can be sure I have the right component there. I also want to go to diode check mode and check these transistors. So we have two 3906s on top and two 3904s on the bottom, and a complementary setup. It definitely could be something in circuit causing this, but all your PN junctions on all of these transistors are showing low. But so do those diodes, like this one here. I know we already talked about it earlier, but right at 0 forward voltage, but it does have a 150 ohm resistor across it. So I will lift one side of that and just double check that it's okay, but probably nothing really to waste more time on the video with. But these transistors, I do need to look at those, at least start taking a couple out and checking them. Meanwhile, I'm going to put a 10K resistor in for R13. I'm just taking a shot in the dark, because if I don't, I might as well stop the repair. So if anybody out there knows what R13 is, as mentioned, it would be helpful to let us know in the video comments. It might help anybody else that has to work on one similar. We'll put R14 back in the plated through hole. And we'll just have to see how R13 does. We'll go ahead and solder these three joints right here really quick. We'll cut the leads and clean up. I do want to take time to check these transistors, so I have removed one. And even though we do show different out of circuit, it's still a little bit odd. So this is a NPN, and the 3906s, they will be a PNP transistor. So now I've removed all four transistors, and just noting that the 3906s are across the top for P1 and P2, which is for PNP. The bottom, N4, N5, are for NPN, or the 3904s. I'm going to bring over my old component tester, and let's just see how it checks in here. Like two resistors. That's not good. And that is the 3904, by the way. We'll go ahead and check another one. This will actually be a 3906. Also shows like two resistors. Yeah, it's not pretty. So I'm going to replace all four of these. I do want to take time to show this new component tester I just got in. I bought this for Nursey to have a backup, and I'm just charging it up here. And so I just want to take time here to see if they're testing these about the same. So the first time using this, I do like the little removable SIF socket. It kind of plugs into the front. Definitely shows as 2 resistors. Let me zoom down. Very nice display, but it is very small. Hopefully it shows up in the video okay. Check another one. I'm going to fast forward through some of this because it does take a little while to test, like all component testers, as it goes through checking. Definitely still resistors on those. I do have my new ones here, so let's see how these test. Definitely shows the NPN, so definitely a 3904. HFE or gain of 156. Let's try another 3904. Definitely shows NPN, gain of 150. Awesome. Let's go ahead and quickly do the 3906s. Definitely shows PNP, 307 on the gain. And the next one, PNP, 312. Awesome. So I like the little tester. We'll definitely be looking at this more as we do other repairs on the bench. Thought I would share a little quick look at this today. Going to go ahead and put in the 3906s, the top row here first. We'll go ahead and bend the pins a little bit and solder these in. Going to put on the flux, and I'm going to bring over this new little micro soldering pencil. This is going to be a very handy little soldering pencil, and I've been wanting one small for a while. You can change the different presets, and I really hadn't played with this a whole lot yet, but I did want to at least show it on video. Now I don't believe even with this larger blade tip it's going to be enough mass to use on this board. I did just want to take time to introduce it and just see if it will by chance heat up enough to get these smaller components, even though this is a very thick board with very thick and long plated through holes. And stepping it up to 680 is starting to work, but I could go over 700 and probably use this, but the other soldering iron is working so well on this thick board, I'll definitely just go back to it. But just kind of wanted to show how handy this little soldering iron is going to be for our smaller devices, and it even comes with smaller tips, which is going to be great for some surface mount things. So we'll be using this more on the bench as well. I've been kind of wanting to get one of these small ones for quite some time, and it actually is starting to flow the solder here, but just a little bit too painful here for this thicker board. But it's going to be very, very handy for the smaller devices that sometimes are hard to handle because they're just so tiny. Let's go ahead and put some more flux on here. This bigger tip's definitely a pain to get in here, but just does a fabulous job with this thicker board. Definitely touching more than you want to sometimes with the big tip, but that's where flux is your friend. You keep flux on here and you can even go across and touch a little. It keeps it separated and the flow really nice. Let's go ahead and do a little cleanup. Cut the leads. And that's what we look like with the 3906s. Now let's go ahead and put in the 3904s. Going to fast forward through doing the same thing. And there we go. We're cleaned up and done. Now if I bring my meter over and go to diode check, are we going to read different than we did before on these 4 transistors? Yep, we sure are. 0.7. Yep. Definitely different. Our PN junctions there are definitely showing up. Let's do a little cleanup here in between, and we'll give this one more look over. And I'm really wanting to do some testing. I don't know if it will be successful at this point, but I want to hook it up and see how it does. So back now we do have the board back in place, and I'll show more detail about that later. If we flip it on, we do get a display, so that's awesome. And it did kind of power on itself. I don't know if that's common or not, maybe. I guess, yeah, I don't have to cut it on. I don't feel anything on or humming. I guess I should at least make sure the unit will cut off, and it does, and back on. Nice. That should be the ultrasonic, and nothing. Not one thing. That's not good. I might have to look at more on the operation of this, but it looks like the power level is up. Maybe I should cut the heat on I know the sound messed up on this video, but the heat clicked on. I'm not going to leave the heat on very long. I don't have any liquid or fluid in it, but just to make sure, I don't think the heat has to be on for the ultrasonic, and no, it's still no ultrasonic. I would imagine with the icon on the screen that it should be putting out. So that's a little discouraging, but I want to do a little bit more testing before I take the board back out, and that is just looking at the kilowatt meter, and I'll kind of throw some footage up here around 2 watts with just the display on. Power is up. You can hear the heat kind of click on, and it goes to right at 500 watts, which is correct. I'm going to cut it right back off because I don't have any liquid in it. And then the ultrasonic, it goes up like a couple watts, but something's going on there for sure. I'm going to go ahead and order one of these chips here, the PWM chip, the 5941N. But I'm going to share with you here, just doing a little bit of testing. It doesn't seem like it's bad. I'm going to go ahead and order a couple just to make sure I have them on hand. But checking here across pin 7 and 13. So pin 7, that is ground, and 13, that's output control. And we get 5 volts. We'll cut it back off and go to pins 7 and 11. 11 being C2, BJT collector output number 2. And we're getting 12.2 volts there. And I also want to go to pin 8, which is really close to 7. But if we look here, the trace goes over to capacitor C27. So I'm just going to grab that leg there, so I'm not touching my probes together. And pin 8 being C1 or BJT collector output 1. And we cut the power on, and 12.2 volts. So back now with the board back out. I have done some testing on this board, and I have found an issue with these Zener diodes. So all 4 IGBTs have this little network with the Zener diode like so. You can see it up here on the top ones as well. Hopefully you can see that on camera. Both of these have it. And getting back to down here, you can see across this one we're reading almost a dead short. Across this D17, we'll zoom in here so you can see more detail. But yeah, 0.6 ohms across this diode. So what I've done is I've lifted the diode, the resistor, and the capacitor here on this network for the Q6 IGBT. And we see with the diode lifted, I'm getting close to 300 ohms. And if I go across the diode itself, I'm getting 1.7 ohms. So these diodes have shorted. These are 1N4744 15 volt 1 watt Zener diodes. And the resistor here showing right at 99K, and we're brown, black, yellow. Should be a 100K, so we're good. I've also lifted one leg on C41 just to make sure it wasn't something going on with this cap, and we are good. So it looks like we definitely have an issue with the Zeners after testing everything in this network. And just to show here on the other side, if we go across these Zener diodes, 1 ohm, and get in here to D19, yeah, basically a dead short. So back now, I have replaced the diode for Q6 as well as Q7 on this side of the board, and now we're getting around 300 ohms with everything back soldered in place. So if we go across our IGBT here, across the gate and emitter, we see almost 300 ohms, and on Q7 about the same. So these two seem to check out now, where they were showing almost a dead short before. And if we look at this side, I have not replaced these two yet, just to show you here going across pin 1 and 3, 1 ohm, and also across pin 1 and 3, less than 1 ohm. So looks like all 4 IGBTs have the same issue. I'm going to replace these 2 Zeners as well, and we'll be right back. So now both of these have been replaced, and if we go across the transistors on this side, we're getting into the K's, which that should be fine. I just don't know why they're different, but they are. But these 2 seem to be the same, and the other 2 seem to be the same. So without schematics, that's as far as I'm going to go. I'm going to put it in now. We're going to retest. I'll fast forward through putting this board back in. We're just going to put the screws back in it and start connecting everything back up, including the incoming power, our ground wires, the actual heater wires, and I have to get the top a little bit closer so I can connect some of the transducer wires and the ground The black wires are common for our transducers. Thermal cutout for the heater. I have connected all 6 of the ultrasonic sensors red wires up to their output terminals. And one thing that'll be hard to see on video is I'm going to connect the ribbon cable. It's kind of short, so I have to have the top almost in place, and I also have this little 2-conductor connector here that takes power up to the display board. So this photo here shows the ribbon cable in place on the board. This is a wider shot of all the wiring being connected on the board in case it helps somebody else. I just reached in and snapped a picture here of what the back display board looks like. And that's the power connector for that display board, as well as the ribbon cable where it comes off the board. So now we're powered back on, and if we test it now, well, we do get some ultrasonic, somewhere around 80, maybe up to 85 watts. I was expecting more than that, but I know this is a tuned circuit and I don't really know how to adjust it. I'm assuming with it empty it'll be the max output, and I'm really not sure about that. I just have this blocked up where I can barely reach in. As you can see, that ribbon cable is about to pull out. I really can't get it up anymore with the way it's set up currently, but I'm going to go in and try to adjust this potentiometer that goes into the pulse width modulation chip. I don't know if this will take the output up or not. Just to be on the safe side, I'm just going to go a half a turn clockwise and just see if it makes a difference. I could put this on the oscilloscope, but I really don't know what it's supposed to be, so I could tell a sound difference, and we got very fortunate that it did go up to 180 watts, so that did increase. So with all these newer components, it probably needed to be tuned to the right output. I do have the specs pulled up, and that's really all I have to go by. And if you can see, our model being an 8800H, it shows 280 maximum sonic power. And I don't really know what maximum means. Maybe we should never exceed that. Maybe it should be set for that. I really don't know for sure. But this is what I have to go by. So I'm not scared to go up to like 200 watts where I would have been without that data. But off camera I have turned it about a quarter round again. We are over 200 watts. It definitely sounds mean. I think I'm going to leave it there, just not knowing how much further to adjust it. Overdriving these could be an issue, or it could just harm you and actually do less cleaning. I'm really not sure. But like anything audio, I'm sure it's a tuned circuit. So back now, I filled it up about halfway with water. I just want to do a really quick first check here. I got some older glasses. I even have some older and dirtier than these. I've just always heard they do a good job with glasses. So let's see if it works at all. And I don't have a basket or anything. They're just laying in the bottom. You know, I don't know if you can see it on camera, but being able to see the whole shape of the glasses and a cloud around the glasses is a good sign. It's definitely working around those tight spots of years of dust and buildup on these older glasses. The surprising thing is, with water in there, it's only about 114 watts. Even though it seems odd, I think the water does dampen it. So I really don't know how they measure the power output or how they test them at the factory. So back now, I just put a small grate in there to keep it off the bottom. I don't know if it'll help or hurt, honestly. I don't really have like a plastic basket to have it suspended, but these glasses are dirtier, so let's just see what they do. These are really, really old glasses, and wow, I see it pouring off. The camera probably don't do it justice. You can just see the cloud form around the whole lens and frame of the glasses. I guess that metal grid is taking the wattage up just a little bit, but still only around 123 watts or so. But it really didn't even take a minute. It's pretty much cleaned all it's going to clean. As far as a longer duration test, I'm going to put this rusty Allen wrench in here and we'll let it go for the full 15 minutes. I don't even know if the ultrasonic cleaner will do anything with rusty metal or not. So this is simply just to see if we can tell a difference in it. Back now, it's been about 4 minutes. Have 11 minutes to go. I really can't tell a difference. The bubbles just hovering in the middle of the water bath is pretty impressive, but I don't really see a lot going on with the oxidation itself. 5 minutes left to go, and I might can see a little bit of rust going in some spots, but it's very, very little. Not what I was hoping for, but again, I don't know what to expect. less than a minute left, so let's check in on it. And I can definitely see a difference, but it's still very minor. It just cut off. So that was 15 minutes. I did not take a snapshot before and after, but I'll try to grab 2 shots from the video and put one above the other, so maybe you can see the difference here. We have the before on top and the bottom is the after. I just tried to freeze frame the video there and show it, and it is a difference. It's just not a lot. I still got the kilowatt power monitor on here at 2 watts, just powered on and ready. And I have some pretty thick aluminum foil here, and I'm going to start with a small piece, and I have a larger piece to test as well. I'm just going to put this on the bottom and we'll let it go for like a minute and just see how it does. And here we go. And wow, I'm already seeing a difference. Even though we're only showing about 81 watts. I do have the water level up almost to the max level, by the way. I did add some water for this test. Didn't know if it made a difference or not. But wow, it's making a dent in that aluminum foil for sure. So we know we're getting some ultrasonic action. I just don't know exactly how much it should be with this model. So it's been a little over a minute, so let's go ahead and cut it off. And how about that? Definitely see through it. So now back with a larger piece of the same aluminum foil. This is the heavy duty aluminum foil, so I don't really know the thickness of it, but it is heavy duty. You might could tell how thick it is when I'm holding it up and it's not folding, it's just staying straight. But I'm going to try it first here on the surface. One spot here on the corner is beneath the water and the rest is on top. Yeah, it's not doing anything except for what's below the water. So back now I have pushed it down to the bottom. I just have it hovering, not quite touching in the middle on the bottom, just to see how the test does. Again, I don't know if a basket will help or hurt in the test. This is just all I have the test with at the moment. So let's go ahead and start it. We'll leave it on for roughly a minute. And man, you can see results immediately. It's definitely picking it up on the microphone. It sounds pretty wicked, especially when I get it close to the transducer output. But yeah, just around 85 watts, so don't know how common that is to be that full, but it's definitely making a dent in it, and quicker than I even would have imagined. You see the water churning a little bit where the surface of the water is getting hit as well. Alright, it's been a little over a minute. Let's stop it. And there you go. Well, might need to put it over here. I can see it better here. Well, how about that? I don't know how it normally would be, but we got some small pieces of aluminum in the cleaner here. So we did get it operational. Do not know if it's 100%. This is the first one I've worked on, and I almost didn't post this video because I obviously don't know much about it and if it's fixed correctly. But hopefully with some of the troubleshooting and at least some of the photos of what I have shared, it may help somebody else also working on one. And on the other hand, there may be some people out there who are very, very familiar with these that might be able to share with me right away what value R13 is or what the value should be and the proper procedure for setting it up and maybe tuning it and what frequency, and all those things will be so helpful, even if not for this unit, in the future, or if anybody else has one they're working on as well. So please check the comments below to see if anyone has shared that information, if you have one you're working on as well. And I hope you found this video helpful. If you did, please like, share, and subscribe. I'm going to have some links down in the video description of some of the tools and items I used on my workbench that was very, very helpful in this repair. Any of those links that you choose to click on are affiliate links, and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.